Okay, in this video, we're going to be looking further into vectors, but here we're using velocity, not speed, velocity. Velocity has a magnitude and direction. Speed is just the magnitude. It has no direction. So let's have a look. Sonia can swim at 3 kilometers per hour in calm water. She swims in a river where the current is 1 kilometer per hour in an easterly direction. Find Sonia's velocity if she swims A with the current, B against the current, and C northerly across the current. So let's have a look at what we have. Alright, what we'll do first, we'll define where our north is. So we'll go north up the page. There's north, which would mean, well, there's east, south, and west. Now we're going to define our vectors. So we've got the river R. Now that's 1 kilometer per hour. We'll go 1k. Now we've got Sonia who swims 3 kilometers per hour. Okay, we don't look at the direction soon, so that's going to be 3 times longer. So let's go. So that's 3k, and that's S, Sonia. So we've got vector R and vector S. So if we look at A, Sonia swimming with the current. So here's our current. Here R. And then we have our vector S for Sonia swimming. We have a resulting vector, which is R plus S. Let's just put S here. Well, then what we can see here, we've got 1, R plus S is going to be 4. So what Sonia swims, 4 kilometers per hour with the current. Okay, that's how we do that. Now, if you look at B, go against the current. So we've got the current's going 1 kilometer an hour this way. Then we've got Sonia going 3 kilometers an hour this way. Then our resulting vector is here. So that's R plus S. Now, what we can see is R plus S is, that's 2 kilometers per hour against the current. The current. Now, as you can see for both of the answers we've done for A and B, we've given a magnitude and a direction for the vector R plus S. We haven't gone, well, with the current is in an easterly direction, and 2 kilometers per hour against the current, well, that's obviously in a westerly direction. But we're still giving the magnitude and the direction. Now, this is the next one. C. It's northerly across the current. So what we have is we have the current, which is R, and we have Sonia swimming across it, which is S. Now, that is 90 degrees in here because it's a triangle. Because it's north and east, then 90 degrees. So our resulting vector is here. That's our R plus S. Now, this might help. There's our north. Now, using our rules of parallel lines, this is theta here. Well, then that's going to be theta there. So, if we find the angle, if we look at the sides we have, we have the opposite and the adjacent. So what we're going to be using is just our normal trig from year 10. Tan theta equals opposite over adjacent, which is r over s. R is 1. That's over 3. Theta equals tan inverse of 1 over 3, which, put that into your calculator, you'll get 18.43 degrees. So that's our direction. We don't have our magnitude, but our magnitude, well, it's a right angled triangle. So what we use is Pythagoras. So that would be r plus s equals 1 squared plus 3 squared equals 10 squared. So r plus s, that's going to be obviously squared. So sorry, it's not 10 squared, that's just going to be 10 because 1 squared plus 3 squared is 9, so the answer is just 10 on its own. My apologies. So the answer for r plus s is the square root of 10. So Sonia swims, the square root of 10. She swims, the square root of 10, it's equal to about 3.2. So Sonia, the answer would be 3.2 kilometers. Let's make that a decent 2 kilometers per hour at a bearing of 18.43 degrees. Now you can do it north 18.3 degrees east, because that's the way we go in a clockwise direction, but you don't have to. I'll be happy with the 3.2 kilometers per hour at 18.43 degrees.